what we're going to use this morning is your graph sheet. Please prepare the Cartesian plane. Divided as usual for equal parts, sections, and you are to prepare your Cartesian plane, 4 of them. Alright, so again, what we're going to do this morning is to draw the graph of a linear equation and also we are going to deduce the equation of a line. Alright? This is done, the line will be graphically given to you. Alright, and based on that line, you are to write the equation of the line. So it's in essence forward and backwards. Alright, we sketch it and then we are going to interpret what that the line or the equation of the line is. Alright? So that is our objectives for this morning. So quickly, please do so quickly because we need to do the first activity. In fact, let me just put this on board and then we'll do a short review on what we have done so far. Okay. Just to recap what we have been doing in the past, okay, for those of you who have finished, I have drawn 4 lines here in the Cartesian plane. Alright? The first line, the red one there, the horizontal line, this line here. What is the equation of this line?
Y equals 3.
Y equals 3. Why is it the line? Why is it that the line is called y equals 3?
The line that is the y.
And one person? Yes, and Zoria? Because the tree. No, it is correct. Perfectly that this is the line y equal 3. But the explanation who can tell me why that is called y equal 3? Does that line has any slope?
No.
Right? It's a plain horizontal line. There is no slope. So a line, what's the general form of a straight line? Cool. What's the general form of a straight line? We have been repeating this in previous lessons. Just a recap. Y equal. Y is equal to mx plus what? Plus c. Alright? Where m represents what? Here y intercept and here gradient. So which one is it?
The gradient.
The gradient, which is the slope, right? This is the gradient. And this is the y intercept, right? So this is the point where the line will pass through the where? The y-axis, the tree, yes. Some people call this is the starting point. This is the starting point, and we will learn more of the starting point when we start to apply these in real life situation. Because some of you may ask, when will we use this in real life? Alright? After we have learned how to sketch the graph, interpret it, then we will see the application of these in real life. Alright? For example, a quick one just to give you an insight here on how we can use it in real life. Suppose you're starting to save money. You start with that certain amount, that's the constant. Starting point, you're starting with $50 and you're saving $10 every week. Alright? So there is a dependent and dependent and independent variable. The x is the independent and the y is the dependent. Meaning, whatever happens with x, it will affect the y. Alright? So that is, in a sense, is how we apply linear equations in real life. So later on, after this lesson, probably this 2 more lessons, we will get into the application process. Where's the word problems? Much many of you like word problems, right? Worded problems. Alright, so that's the best. So we will be applying these. But we cannot do this or that unless we learn how to plot the points, identify the equation of the line, or simply look at a line and know the equation of it. So we will be doing that. Alright, so this is the starting point, y-intercept. This has a y-intercept. But what happened? Why this doesn't have any m? See? Y equals 3. Right, because there's no slope. There's no inclination. So that is why this line is y equal to 3. Alright, so similarly then, if this is y equal 3, what will be this line?
Y equal -5.
Y equal -5. What analysis can you make by between these two lines? What can you say about when you look at these two lines? Y equal 3, y equal -5. What can you say about that? Huh? Alright, so let's wait on that. Let's look at these two. Then probably you will be able to tell me. What is the equation of this line now? X equals 3. Alright, and this one? X equal -8. Don't draw your line like my one, right? This will be right over the line. So like this one, you have to do it. Should be like this one. Many of you like to do your lines like this. Alright, so please, you need to ensure that your ruler is straight and you draw your line right over the line here. Okay, so now probably you can answer that question that I asked earlier. What relationship or what difference do you notice between these two lines? Horizontal lines and vertical lines. What can you say about that? Huh? Y goes horizontal, and what about the X? Right. How are those lines in relation to the axis? Look at the axis. The x-axis, and look at the equation of the line. They are? No, they're not the same. They're opposite. Right, they're opposite. So if we're talking about straight lines with no inclination, that means they will be opposite. If this is the x-axis, then this will be y equal. Alright, so the equation of the line, the x-axis is what? That's the equation of the x-axis. X equal?
0.
Sure. We're just saying that horizontal lines have what? Y. So this will be what? Y equals 0, right? See? You have to be careful. It's y equals 0. And then the x-axis, the y-axis will have x equals 0. Alright? one of the reasons they're intersecting at 0. Alright, so x equals 0, y equals 0. Alright, so this is the general simple linear equations. The lines that don't have an inclination. Alright, now, yesterday we were working with the graph of other equations. Alright, with the slope having a slope or a gradient. And I noticed many of you were having problems understanding that. Either one will have whole number and one that has fractions. So today, we're going to continue with it. And at the end of this lesson, you should all be able to properly or correctly or accurately sketch the graph of a linear equation. So I want you to just get in groups, just move like this with this with that, and that with that. Any one option, just what I want is to help each other so that if there is anyone that doesn't know, then you assist each other. Just do it quickly. Okay, so in one of the Cartesian planes that you have divided your graph sheet into 4. I want you to plot these points, draw the graph of these. Right, and then this on the other side. Right, so you are going to do this by graphical method. Right, you are just going to count the whatever. Remember, each of these equations are in the form of the general form of the straight line, meaning y equal mx plus c. Alright? So a few minutes and I will ask some of you to come and sketch. Alright, or at least give me the coordinates and then I will sketch it on the board. Ask him. He don't know either? What's the first thing in general? What's the first thing that we are supposed to do? See what I wrote here? The starting point. What is that? Y-intercept. So that's the first point we need to identify. Alright, so go ahead in your Cartesian plane and identify the starting point. And notice I'm circling the sign as well. Plus. So if it's negative, then you know where it will be going in the Cartesian plane. So your first point will start. What's the second thing that we said here? The gradient. There's a formula when you're doing graphically. What is that? Rise over run. Alright? It's a fraction. So notice these are not fractions as they're in that manner written. It's not written in the manner as a fraction. But can you write 5 as a fraction?
Yes.
Which is? Right, exactly. So from 5 positive. 5 positive. No. Where's the starting point? It will be the y-axis. The y-axis. Alright. I noticed some people still having problems with it. Let me do an example. Let's say you have y equal 3x minus 1. This is the starting point, is the y-axis, y-intercept. So where will I locate that point? In the y-axis. So in the y-axis, I will identify that point. It's my first point. -1 in the y-axis. See? That is the y-axis, -1. Then the gradient is 3. But gradient is as a fraction, rise over the run. So 3 as a fraction is? How much? 3 over 1. So I will rise. 3 since it's positive, I will go up or down? Up. So I will count. Do not count 1, 2, 3. From here to here is 1, 2, 3, and then run 1 positive. If I go so it's positive, I go that way, it will be negative. So I want positive. So that is my point. And then I draw my line. Alright, so then that's a -1. And you need to be exact. Remember, graphing is precise to the point, and that is the line. Right? Then there you write y equal 3x minus 1. Alright, so those of you who are still not understanding, I hope that has helped you a little bit. And that is how you should sketch the line. So use that as a guide. First one? No, it's not right. Check it again. Then you go 5. One. You went to 6. 1. How do you think I knew that something wrong with that just by looking at it? If you don't know, you should be discussing with your partner. The idea is that you all understand. Everyone understand or know how to draw, sketch the line. Kindly extend the line. Just don't limit to the sharp like segments there. Extend the line far beyond the 2 points. Alright, we only need 2 points to draw a straight line. Extend the line. Just don't leave a very sharp line from the points that you have drawn. Alright, extend the line to the size of the Cartesian plane. If I extend that line, I will eventually eventually this line will be intersect with that line. Something I've been drawn for probably next point. That's 1, 2, 3, 4, 5, 1. It's probably this one because you should have done a little bit. This line should have been a little bit longer. You see the second one? It's a positive 3, then you went 1, 2, then you roll 5. 1, 2, 3, 4, 5. Right, perfect. Negative 2. And then you went 3, 1, 2, 2, 3, 4, 3. Then 1, 2, 3, 4. Then you draw the line. Right, perfect. Move on. You got it, Brittany? Same thing? You understand fully now? How about you? You have to write the equation of the line. So when I look at the line, I can interpret it. Just like how I wrote the equation of the line on the board. But y equal, remember it's an equation. So 1, 2, 3, 4, 5. Since at minus 2, you come 5. 1, 2, 3, 4, 5, and 1 to your right. Yes, 1 right and 2. It's 5 over 1. So that line is not correct. Which one is that? Y equal 5x plus 2. So you start at where? On the y-axis at 2. At 2. Right, then you count the same thing. 5 positive. Will you go up or down? If you go down, will you add the numbers be positive? No, so what do you need to go? Up or down for 5? Up. Alright, you need to go up 5 units. Finish with that? Come on. Okay. 5x plus 3. Plus 3, then you need to go 1, 2, then 1, 2, 3, 4, 5. Why are you going that way? But the negative is only applied to either the 45. I think you had the same issue yesterday, remember? You only apply the negative either to the 2 or the 5. You can apply it to both of them. Because if you apply it to both of them, it will be positive. But it's a negative. So negative 2, you will go down, 1, 2, and the 5 is positive, right? And remember the lines that have the slanted like this, they are positive. Lines that have the slanted this way, the gradient is negative. So the moment you're sketching your line, and you notice that your line is coming up something like this, and the gradient is positive, that's an indication that you have done something wrong. Alright? Like a few examples I've seen over that I've been walking around. Alright? So, positive gradients come this way. Negative gradients will be this way. Alright? I explained that last class. Alright, so you have to be careful. And remember, when you have negatives, the negative is only applied to either the numerator or the denominator. This is not right. Again, this line must pass right at negative 2, not by side, right at negative 2. But you see, this is positive 2. Why are you doing it in negative? This is a positive, it must pass at positive. You have it different, you have it not in the correct order. So you put 5x minus 2, which in essence is here. Right? And you cannot have a graph like this. So if you notice in your minus, that means this is going to happen a little bit. So it's going to start. Same thing with this. Just by looking at it, I know something is wrong. At negative 2, then I count 1, 2, 3, 4, 5, 1. See where the arrow should be? And likewise, you can't have that. So you need to start going like that. Questions? Right now, this 5, correct? Sorry, 3, that's negative 2. 3, 1, 3, then 4. Correct. The same thing I said, you extend the line. And this one Right. Very good. Excellent. Perfect. Plus minus 2. Then it is 3. 1, 2, 3, then 4. Correct? Positive 3 minus 2. And 5. Right. Correct. Correct. So the same? Alright. Excellent. Boom. Got it? Where's the second set? Haven't done the second set? Alright, same thing here. You need to write the equation. Alright, so when I interpret the lines, I need to see the equation of the line. Alright, let me see. Plus 3 minus 2. 1, 2, 3, 4. 5, right. Then minus 2. I go 3. 1, 2, 3. 1, 2, 3, 4. Right, very good. Make sure you explain to him. It looks like he's having a little bit of problems. Aragon, same way. Let me see the first one, Aragon. You haven't done none of them? You just learned the first one. What's the problem? Let me help you. Let me see.
I can understand what
Well, that's a starting point, remember? You start at minus 2 on the y-axis. No, you start right from the point. Starting point. Yeah. 1, 2, 3. How many units should go? So you call 5. Start. Yeah, right there. Put the point. Yeah, only you need 2 points to draw a straight line, don't draw your line. Extend your line, extend your line. You want the 2 points. No, don't move your ruler. It should be a straight, one smooth line. Don't move your ruler. Just move, I'm not afraid to draw your line. Halfway to the end, yes. Write the equation of the line. Alright, you get that one? So I'll come back right now, try the second line. Second equation. Right now. Let me see. 7. It looks like you know to count this. You have to count this. 1, 2, 3, 4, 5, then 1. So that was your mistake there. Let me see. This is plus 3, then minus 2, 1, then 5. 1, 2, 3, 4, 5. Correct. Equation of this, I don't know what that is. Minus 2, what it looks like you have 1, 2, 3, then 1, 2, 3, 4. So right now we do that one is correct. Just that first one, the counting is alright, I think about most of you have given any of the drum. 2, the first 2. How about the others? Still not there yet? Huh? Dorian? Same thing? Alright, let us look at it in the interest of time because let us look at it. And then take one of those. Alright, let me have on your screen here. Alright, so let's look at the first one. And those of you are not understanding, so let us pay attention. And if you have any question, please let me know. Alright, so the first one, it says 5x minus 2, y equal 5x minus 2. Like I mentioned earlier, the -2 is the starting point. This 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 is the starting point. Alright, all of these we will find those in the Cartesian plane, the y-axis. Right on the y-axis. So those are the starting points. So keep that in mind. So then the other one, the 5, is the gradient. So for the first one, the starting point is what? -2?
Yes.
So that is my first point. Although I'm writing the point big here just for you to view it, but you should just have that there so there's an indication where the line will pass through. And then the gradient. If you notice, the gradient is 5, but we need a fraction. It's 5/1. So that means we rise 5 units because it's positive, we go up. So I will start counting. 1, 2, 3, 4, 5. That's the rise, and we run 1 positive. And that is the second point. Once we have that, then we draw our line and ensure that the line passes exactly at the marked points. Not over or lower. Alright, then you draw your line. And then I can write the equation. Y equals 5x minus 2. Any questions? Any questions? Everyone understood clearly what to do when you're given an equation to represent it on a graph? Alright, let's look at this. Let's do the second one. 5x plus 2. Now this, the starting point is positive 2 on the y-axis.
Yes.
So it's positive 2 right here. And we are going to go, again, the same 5/1. So we're going to go 5 units. 1, 2, 3, 4, 5.
One
And 1 to the right.
and connect the dots.
And now, right, we just need to connect the dots. And that will be our line. Ensure that the line passes right at the intersection of those points. And then I draw my line. Alright, and there we have it. And then we put y equal 5x plus 2. It's important that you write the equation of the line right on the line. Now, just adding to this, what do you notice about those two lines? They are parallel to each other, right?
Yeah.
So we can safely say that whenever two lines have the same gradient, the lines are parallel. Same gradient, the lines are parallel to each other. Alright? Just a side note there. Because we will discuss this later on, but since I have that, we'll just highlight that one time. Let's look at the second one, which I noticed a lot of those of you who have completed it is because of this one here. So let us do that. Alright, so that's clear there. Okay, so now, again, the starting point of this number 2, the first one, is what? Positive 3 on the y-axis. Positive 3. Then, the gradient is how much? M equals -2/3. Alright, so again, it's rise over the run. Since the rise, I am attaching the negative to the numerator, which is the -2. I will go up or down? Down, because notice if I continue here, I will get to negative numbers. So I go down. 1, 2, and then you run. See, rise over the run, 3. 3 is positive. 5. Oh, my bad there. Not writing properly. See what happens. 1, 2, and then I run 5. 1, 2, 3, 4, 5. Then I mark my point. And once I've done that, I draw my line. Alright? I draw my line. More or less here. Don't be afraid to extend the line, right? I told you I could extend the line and really pass the points. So this is y equal negative 2/5 x plus 3. Right? Any questions, Ivan? What is still not clear? Do you understand the starting point?
Clear.
Alright? So see, the second part you have to look is this negative 2/5. You start with the numerator first. Since you are attaching it to the negative 2, you go down 2. Negative, you go down. Then is a 5. Positive, so you go to your right. That's how. Just count. Put the points where you will finish counting and then you draw your point. Alright? Let's look at the second one. Again, the starting point is what? Negative
2.
Negative 2. Alright, so this is the starting point, negative 2. 3, 4. Those are positive. So we're going up. See, as compared to this where we had negative 2, we went down. But since this is positive, we go up. 1, 2, 3. Do not count like this. Some of you are counting like this. 1, 2, 3. Wrong. Or other people are counting 1, 2, because the 0 they don't count it as one skills. Alright? It is counted as well. So it's 1, 2, 3, and then you run how much units?
4.
Left or right?
Left, right.
Right. 1, 2, 3, 4. Once you have your 2 points, you can safely draw your line. Right, and there is the line. Y equal 3/4 x minus 2. And that is what we have for that. Dividing? A little better? Sosa? Alright. Cool! I noticed you never did this. Have you understood it properly now? Clear understanding? At the back there, Joshua and the company? But the company. Alright, so make sure they learn that part. Alright, now we go to the second part. We might not have a lot of time. Alright, but it's important that you learn how to sketch the line. Alright, it doesn't matter if we spend a little bit more time, but I notice more people are having a better understanding. Alright, so now what I will do, I will sketch a line and then you will tell me the equation of the line. Alright? So we're going backwards now. Okay, so let me. Now, given a line, you are to sketch or write the equation of the line. Draw this line. Oops, not properly. Sorry. Okay. Let us write now the equation of that line. From where can we remember? Y equal mx plus c. What's the first thing that we need? Starting point. Where is our starting point? The y-intercept. So where is that line passing through the y-axis? Positive or negative? Positive, right. So we have our equation y equal mx plus c. So our equation will be something like this. X, we already identified plus c, which is plus plus 1. What is left?
Find the gradient.
The gradient. Now we need to find the gradient. The gradient again is rise over the run. Remember when we draw the line? We counted boxes. So the same we were going to do. So what is the gradient of that line?
4 over 3,
4 over 3?
Yes.
How you get that?
The gradient of the ball 4 and go find 3 things later. No, wait. 4 over 3. 2 over 1.
Okay. Let me. Some of you are giving fractions or are giving a number. What are you giving? The fraction or the gradient? What's the gradient? 2. How did you get 2?
1, 2, and 1 3.
1, 2. Come on, show us. How you found it? Can you- From where you're starting?
From here. I count 1, 2, and 1 3. 2 and 3. Why?
Not exactly like that. Alright? Who else wants to try? See, it's just the backwards of what we just did. Rise over the run. We counted from the starting and then we ended putting another point. So it's 2 points. Alright, so the time is on us. So just quickly to close up on this, is the gradient is rise over the run. So from this point, and let's say to this point, 2 points. How much are we rising? 1, 2, 3, 4. So M equal 4 over. How much are we running? 1, 2. 4 over 2. So M is equal to how much? 4 divided by 2 is 2. So the gradient is 2. So therefore the equation of that line is
4 over 2. I mean 2.
no. The gradient is 2. So this will be y equal 2x plus 1. See? Backwards down. Alright? In the next class, we're going to continue with this. I'll give you some additional lines and then you'll write the equation and then we'll look into the application process. Having said that, thank you very much for your attention. Continue reviewing on this. Alright? Having said that, thank you. See you next class.
Yeah,
Bye bye.